Berlin, the year 1938. The Reich Air Ministry. A room full of senior officials hunched over a set of blueprints on the conference table, and the color had drained from every face in the room. The drawings in front of them broke every rule of aeronautical engineering they had ever learned. The crew cabin wasn't positioned along the center line of the fuselage, the way it was on every aircraft ever built. It was shoved hard to the right. The engine sat off to the left. The whole thing was lopsided, in a way that made several of the men physically uncomfortable. One official slammed his hand on the table and declared that this thing would never get off the ground, that it would cartwheel immediately after takeoff and kill everyone aboard. The rest of the room agreed loudly. The man who had drawn the blueprints, 40-year-old designer Richard Vogt, stood at the end of the table and said nothing. He had a face like a closed door. Vogt had spent time in the trenches during the First World War, had flown rickety observation planes over the Western Front, and had absolutely no interest in the opinions of men who had never left their offices. In aviation circles, he was known as an obsessive and an awkward customer, the kind of engineer who would rather spend 3 years proving everyone wrong than take the easy road and build something conventional. The whole situation had begun months earlier, when the Air Ministry announced a competition for a new single-engine reconnaissance aircraft. The requirements were specific: a 3-man crew, outstanding downward visibility for spotting enemy positions, and enough speed and agility to survive in contested airspace. Single engine only, simpler to produce, cheaper to run. Invitations went out to Arado, Focke-Wulf, and a few others. Blohm and Voss didn't receive one, because the company's reputation was built entirely on seaplanes and flying boats. Vogt didn't care. He had been sitting on this idea for long enough. The idea itself was deceptively simple once you understood the problem it was solving. Every aircraft of the era followed the same basic arrangement. Engine on the nose, cockpit behind it, everything perfectly mirrored left to right. It looked rational. But Vogt had been cataloging the hidden costs of that layout for years. The crew sat directly behind the engine, which blocked everything they needed to see. The propeller wash created turbulence that beat against the control surfaces and made the aircraft restless in the air. And the engine torque, the rotational force produced by a spinning propeller, constantly pulled the nose sideways, so the pilot spent every flight making small corrections just to hold a straight line. Vogt's argument was that so-called symmetrical aircraft were already flying asymmetrically. They were just doing it badly and making the pilot compensate. His proposal was to build an aircraft that was asymmetrical on purpose, designed from the start so that the offset layout would cancel out all those competing forces rather than leaving the pilot to fight them alone. Walter Blohm, who owned the company, listened to this pitch and didn't laugh. He was a businessman with a longer view than most. His personal theory was that the war was temporary and that commercial aviation was the actual future, that flying boats would eventually replace ocean liners on transatlantic routes, and that the company that got there first with the best technology would dominate the market. For that reason, he had always pushed his engineers toward unconventional solutions. When Vogt walked in with drawings of an asymmetrical reconnaissance plane that the Air Ministry hadn't asked for, Blohm saw it as exactly the kind of thing that could put Blohm and Voss on the map. He signed off on the project on the spot. Vogt's engineering team threw themselves into the work with the kind of energy that only comes from knowing you're building something no one has ever built before. The layout they settled on placed a WW2 engine in a dedicated left-side nacelle that extended all the way back to the tail. On the right, attached to the wing, sat a fully glazed crew gondola made almost entirely of plexiglass, pilot up front, observer in the middle, rear gunner at the back. The view from inside that gondola was unlike anything available on any other single-engine aircraft of the period. The crew could see forward, downward,
sideways, and partially behind them, without a single structural element blocking their sightlines. Vogt had done the aerodynamic mathematics himself, working through calculations that most of his colleagues considered either brilliant or delusional, depending on who you asked, and he was convinced the aircraft would fly straight. The first prototype rolled out onto the airfield in late 1938, and the reaction from everyone present was roughly the same. People stopped what they were doing and stared. The aircraft looked like something that had been assembled by someone who had never seen a real airplane. Two mismatched halves bolted together and somehow expected to fly. The test pilot assigned to take it up walked around the machine several times without saying anything. Then he walked around it again. The ground crew placed quiet bets on whether it would leave the runway at all, or whether it would simply veer off sideways and end up in a ditch. Vogt stood apart from the crowd with his hands in his pockets, outwardly calm, privately aware that if this flight went wrong, his career in aviation was finished. The engine fired. The propeller bit into the air. The aircraft rolled down the strip, shaking and rattling in a way that did nothing to reassure anyone watching. Then the nose came up, the wheels left the ground, and the machine climbed, steadily, cleanly, without drama. Nobody breathed for the first few seconds. Then it became clear that the aircraft was not going to roll over, was not going to snap sideways, was not going to do any of the things the Berlin officials had predicted. The pilot completed a circuit of the airfield, ran through a series of maneuvers, and brought the aircraft back down without incident. He climbed out looking shaken but composed. His assessment? This machine handled better than several conventional aircraft he had flown. Word traveled fast. One of the people it reached was Generaloberst Ernst Udet, First World War ace, close associate of Hermann Göring, and one of the few senior Luftwaffe figures who was an actual pilot rather than a bureaucrat in uniform. Udet understood aircraft from the inside out, and when the test results for the BV-141 crossed his desk, he didn't file them away. He arranged a personal demonstration, flew out to the airfield, spent time examining the aircraft on the ground, asked detailed technical questions, and then climbed aboard as an observer for a flight. Afterward, he was openly enthusiastic. The aircraft met nearly every requirement the ministry had set, and in some areas went beyond them. Udet committed to backing the project and began working his way through the upper levels of the Luftwaffe hierarchy to build support. Göring himself was the obstacle. The commander-in-chief of the Luftwaffe was a conservative when it came to aircraft design, deeply suspicious of anything that looked experimental, and he had already made up his mind that the Focke-Wulf FW189, a twin-engine design with a conventional glazed central nacelle, nicknamed the Uhu, was the machine the Luftwaffe needed. The fact that the FW189 used two engines and therefore technically violated the ministry's own single-engine specification didn't seem to bother him. He considered the twin-engine layout safer and more reliable, and he said so repeatedly. Meanwhile, Arado, who had been quietly promised the contract before any competition had officially taken place, finally delivered their own prototype, the AR-198. It was a disaster. Unstable in the air, underperforming on every metric, the AR-198 was grounded after a handful of test flights, and the project was cancelled without ceremony. That eliminated one competitor, but Focke-Wulf and its well-connected patron remained very much in the picture. On April 4, 1940, the Air Ministry's Evaluation Commission arrived at the test airfield to watch the BV-141 and the FW-189 fly against each other. The trial covered everything: speed runs, maneuverability tests, stability assessments, crew visibility evaluations, and reconnaissance performance at various altitudes. Both aircraft acquitted themselves reasonably well, But the BV-141 had a clear edge in several categories. The single-engine layout made it cheaper to build and simpler to maintain in the field. The glazed gondola delivered better all-round visibility than the FW-189's central cabin, largely because there was simply more glass and fewer structural interruptions. And the aircraft's handling, the thing everyone had predicted would be its fatal weakness, turned out to be excellent. The Commission's written conclusion acknowledged that the BV-141 met nearly all of the Ministry's requirements and showed genuine potential as a frontline reconnaissance platform. Udet used that report like a crowbar. He pushed it through every committee and working group he could access, arguing that the asymmetrical aircraft was exactly what the Luftwaffe needed for effective reconnaissance across all operational theaters. Despite Göring's continued resistance, the Air Ministry issued a production order in 1940 that stunned the German aviation industry. 500 aircraft. For Vogt, for Blohm, for every engineer and draftsman who had spent years on this project, it was the moment that made everything worth it. The aircraft that officials had called madness was now scheduled to become one of the Luftwaffe's standard reconnaissance types.
Planning documents from that period show particular emphasis on the Eastern Front, where the BV-141 was expected to play a major role in the reconnaissance operations ahead of Operation Barbarossa. The celebration inside Blohm and Voss was everything you would expect. Engineers who had barely spoken to each other during the pressure of development were suddenly best friends. Mechanics opened bottles. Vogt himself, a man not given to outward displays of emotion, allowed himself a rare smile. The company began preparing for mass production. New workshop space, new equipment, additional workers. A more powerful version of the aircraft was already being designed. The military was drawing up deployment plans, training observer crews, and mapping out deep reconnaissance missions into Soviet territory. For a few weeks, everything pointed in one direction. Then the problems started surfacing. As the engineering team dug into the practicalities of series production and began pushing the aircraft harder in extended testing, issues that had either been missed or quietly set aside began demanding attention. The most serious one had nothing to do with aerodynamics. It had to do with the crew sitting inside a box made almost entirely of glass. That gondola, the feature that had won the aircraft its contract, was a death trap the moment anyone started shooting at it. Even armored glass couldn't reliably stop rifle-caliber rounds, and any enemy fighter or light anti-aircraft gun could turn the crew compartment into a colander in seconds. The men who were expected to fly these missions began saying so directly. Several pilots stated flatly that they had no interest in going to war in an aircraft where they were visible from every angle and protected by approximately nothing. The second problem was aerodynamic and had been lurking in the data since the early test flights. The rudder, mounted on the tail of the engine nacelle, was catching disturbed air from both the propeller wash and the asymmetric fuselage arrangement. This turbulence made the rudder fight back against control inputs, which was manageable on short evaluation flights, but became genuinely exhausting during the kind of long reconnaissance missions the aircraft was actually designed for. Engineers cycled through modifications to the rudder's size and shape, but fixing one aspect of the problem invariably created a new one somewhere else in the control system. A third issue emerged when the aircraft was fitted with its full complement of weapons and mission equipment. The additional weight shifted the balance further toward the crew gondola side, and the wing, designed around the original weight distribution, was no longer long enough to compensate. The solution was to extend the wing, which added more weight, which reduced speed, which required further modifications elsewhere. Every answer generated two new questions,
and the development team found themselves trapped in a cycle of diminishing returns that consumed time and resources the program couldn't afford. Work continued regardless. By 1941, 3 full prototypes and a batch of 5 Series A evaluation aircraft had been completed and were undergoing intensive assessment. These machines used the WW2 engine, producing 865 horsepower, giving a top speed of around 438 kilometers per hour, a range of roughly 1,900 kilometers, and a service ceiling of 9,700 meters.
Respectable numbers for a reconnaissance aircraft. But the military wanted more speed, more power, and better crew protection, and they weren't shy about saying so. The engineering team responded with the Series B variant, which was intended to be the actual production aircraft. It received the WW801 engine, 1,560 horsepower, substantially faster than anything the WW132 could deliver. The horizontal tail was redesigned and made deliberately asymmetrical. The right-hand stabilizer was removed entirely to improve the rear gunner's field of fire and give the observer a cleaner downward view. The aircraft now looked genuinely bizarre from any angle. Engine to the left, crew gondola to the right, and a tail that was missing half of itself. Armor protection on critical components was increased, though the fundamental vulnerability of the glazed gondola was never resolved. Additional machine guns were fitted for self-defense. Around 12 Series B aircraft were completed by late 1941 and entered intensive evaluation. The new engine had delivered on its performance promises. Everything else remained complicated. The Air Ministry's final decision came down like a guillotine. Officials had run the numbers and concluded that the BV-141 was simply too complicated and too expensive to produce at the scale the war demanded. Germany needed aircraft by the thousands and needed them quickly. An asymmetrical design where almost no component could be mirrored or swapped between left and right sides, where every single part was effectively unique, was a production manager's nightmare. The man-hours required to assemble one BV-141 were significantly higher than for any conventional aircraft of comparable size, and in the industrial arithmetic of total war, that gap was fatal. There was also the question of engines. The BMW 801 units earmarked for the Series B were urgently needed elsewhere, specifically for the Focke-Wulf FW190 fighter, which was being rushed into service to defend German airspace against increasingly heavy Allied bombing raids. Every engine bolted onto a reconnaissance aircraft was one fewer fighter in the sky over the Reich. The existing fleet of FW189 twin-engine reconnaissance aircraft was performing adequately, and its production line was running smoothly. There was no compelling operational argument for disrupting that line in favor of a more complex and still troubled alternative. The order for 500 aircraft was cancelled. Production stopped at approximately 12 completed Series B airframes, though later archival research suggests the total across all variants, prototypes, Series A evaluation machines, and Series B aircraft was closer to 20. For Vogt's team, it was a blow that took the air out of the room. Every late night at the drawing board, every argument with ministry officials, every test flight and redesign and compromise had led to this: a cancelled order and a handful of aircraft parked on a field going nowhere. Vogt himself refused to accept it as final. He kept working, kept filing proposals, kept developing improvement concepts on the assumption that the ministry would eventually change its mind. Design studies for 38 different modifications were completed. Different engines, different armament configurations, different mission equipment packages. None of them were ever built. Then came the event that closed the door permanently. In 1942, Allied bombers hit the Focke-Wulf plant in Bremen, the facility producing the FW200 Condor,
a four-engine aircraft used for long-range Atlantic patrol work and, more notably, as Adolf Hitler's personal transport. The raid effectively destroyed the factory. Production of the Condor stopped completely, and the German High Command needed a solution immediately. Their eyes settled on Blohm and Voss. The company had the floor space, the skilled workforce, and the experience with large aircraft construction that the situation required. The Air Ministry issued an order: stop all current projects and begin licensed production of the FW200 without delay. Walter Blohm was furious and entirely powerless. Every resource the company possessed was redirected to building someone else's airplane. The BV-141 ceased to exist as a going concern. The completed aircraft sat on the apron and deteriorated. Rain got into the airframes, snow settled on the wings. Not one of them ever flew a combat mission.
The plan to deploy asymmetrical reconnaissance aircraft ahead of Operation Barbarossa, to use them for mapping Soviet airfields, fortifications, and troop concentrations before the invasion, was never executed. A small number of the airframes were used for equipment trials and crew familiarization flights, but that was the extent of their operational history. As the war turned against Germany, most of the surviving BV-141s were either stripped for parts or deliberately destroyed during the retreats to prevent them falling into enemy hands intact. When Allied forces pushed into Germany in 1945, soldiers occasionally stumbled across the wreckage of strange, lopsided aircraft they couldn't immediately identify. British technical teams recovered at least one reasonably intact example and shipped it back to England for detailed examination. RAF engineers stripped it completely, analyzed the aerodynamic solutions, studied the structural approach, and wrote up their conclusions. The verdict was measured. The concept was bold and the engineering was competent, but the aircraft was too vulnerable in combat and too difficult to manufacture at scale. American technical teams reached similar conclusions after examining at least one additional example. Interesting experiment. Impractical weapon. No BV-141 survived the post-war period. Every example was either destroyed during the war, dismantled by Allied technical teams, or simply left to rot. There is no restored airframe in any museum anywhere in the world. The aircraft exists only in photographs, in engineering drawings, and in the written accounts of the small number of people who actually saw one fly. As for Richard Vogt, the man who had drawn those blueprints that turned ministerial faces white back in 1938, his story took an unexpected turn. American intelligence had been running a program called Operation Paperclip, which was quietly extracting German scientists and engineers from the rubble of the Third Reich and relocating them to the United States before the Soviets could get to them. Vogt made the list. His experience with unconventional aircraft structures was exactly the kind of specialized knowledge the Americans wanted to preserve and exploit. He was brought to the United States, where he worked on experimental concepts, including nuclear-powered bomber designs, aircraft theoretically capable of flying for weeks without refueling, which were about as practical as anything else that came out of that particular era of optimism. He later joined Boeing as a civilian engineer and remained there until retirement. The man who built the strangest aircraft of the Second World War ended his career quietly, in peacetime, doing honest work for a company that made very symmetrical airplanes. The BV-141 itself left no physical trace, but as a demonstration of what happens when a genuinely original engineer refuses to accept that the conventional solution is the only solution, and what happens when the world isn't quite ready for what he builds, it remains one of the more instructive stories in the history of aviation.